The webinar has started. Hello, everybody. Attendees are still joining. Thanks for joining us today for the Scan to BIM 301, the last of our three-part series. We're going to give just a couple more minutes here. I know we're right at the time, and we like to give a couple minutes. People are still joining in kind of rapidly, so we'll get kicked off here in just a moment. Thank you again for joining us today.
Well, we did this last time, so I'm going to do it again because now it's like a thing, and I feel like we jinx ourselves if I don't do this. So what's everybody drinking? What's everybody drinking today for the webinar?
I forgot. I don't have anything.
Oh
my mouth's gonna be so dry by the time we finish this. It's gonna be horrible.
Oh man.
Might have to wave somebody down outside the conference room and like
good old water.
High quality Lake Erie, Michigan water.
Oh, we got two healthy people on the call. We have one forgetful person, and then there's me with my Dr. Pepper.
Don't call me too healthy. Fair.
Oh, sorry. If I was drinking water, it would be Poland Spring, the pride of Maine. So that's we just have to have that.
I at least get my water in like once a week. Other than that, you will find me with coffee. So I'm not, this is a rare occasion.
Duly noted. You're healthy just for us.
Don't give me too much credit here. So.
And as usual, our audience has already chimed in. We've got some, Michael Horn is drinking sweet tea. Is that a Linus Tech Tips water bottle, Matt?
You know what? I actually don't know the exact water bottle. It is a thermo flask. There you go. That is the actual. And it is branded with the beautiful state of Idaho, where I reside.
And Ken Peters has asked if anybody has the recipe for the Pan-Galactic Gargle Blaster.
What is that?
I can't say I have that on hand.
That's going to require an explanation later.
More information.
Yeah. I want to Google it, but I'm on a work computer right now. I don't know if that's appropriate.
Sounds like
at least you're on your own Wi-Fi.
Oh man.
All right, guys. Well, we've still got people joining, but out of respect for everybody's time, I think we will go ahead and start with our introduction slides here. And Kelly's going to give some rules for the day, and we'll get rolling.
Indeedly do. Yeah, so just so everybody knows, of course, our participants are muted. I think we peaked just under 500 on the first one and over 400 on the second one. So if we had all of you unmuted, it would be a total disaster. So yes, you will be muted. Please ask your questions via the chat. So I should say through the questions panel during the session. So there's a little questions thing on your little GoToMeeting sidebar if you've got questions, or including the recipe for the Pan-Galactic Gargle Blaster. That's the place to pop them in. We will take those kind of on the fly if it relates to the topic that we're talking about. So by all means, please start popping in your questions as they come to mind. We will have a Q&A at the end. What we've done the last couple times is if we didn't get to questions during the thing, we tried to go through them after the time is up. So we've ended up running about 25-30 minutes past the webinar time each time, but it's all recorded. So if you actually have a hard stop, you can always snag the recording and hear all the questions getting answered at the end that we can, and then eventually we have other jobs too, and we will cut it off and we'll do a follow-up session the next week to answer any remaining questions.
And one more thing on that note is those of you that are with us today but maybe missed even the first two sessions, all the sessions have been recorded. So if you missed one and you're still looking for it and/or you don't see it for this one, just reach out to us and we'll make sure you get access to them.
Absolutely, and please do go check out the LinkedIn group for Scan to BIM University because we've got a bunch of stuff on there as well, links to the prior sessions, etc. And there's been some nice conversations happening on there, people asking questions. So check that out. And with that, let's actually do our introductions. Sean, please take it away, sir.
All right. So my name is Sean Doyle. I'm the reality capture manager at Bond. We are a construction management company out here in Boston. And so I kind of helped co-develop our laser scanning program. About 8 years ago, we were kind of familiar with point cloud data, using point cloud data, but we had the bright idea one day of like, why don't we just start getting the data ourselves, really, and kind of a self-taught process over the last 8 years. A lot of hardship and pain for sure, but now at this point we're pretty checked into what we got going on, and how to use and leverage the software, both kind of as a construction process, so supporting the construction process, whether it's pre-construction or it's doing as-built or QA/QC stuff, and then also kind of working directly for our clients and saying, hey, you can leverage this technology to pre things and to prefabricate as much as you can as possible. And so for the last 8 years, I've spent a fair deal of time kind of developing those processes and trying to kind of connect with our clients to help streamline their design process. And just to add, Kelly, because I know you're a pretty good dancer, I'm just here to balance the group today. So good dancer, bad dancer, we got to keep it on an even playing field.
Fair enough. All right, Mark, Mr. Laser Shark LaBelle, Mr. Last Minute LaBelle, please take it away.
Hey, as I've always say, I always reserve the right to edit my presentations until they've been delivered, right? You can't edit them once they've been delivered.
There you go.
For those that know me, that is a common theme with me. I do like to constantly tweak my presentations. It always makes it a little bit more fun. But started working, like Sean, very early on in the laser scanning, started in 08 with our first project, which was an absolute disaster in many ways, but we learned such great lessons from it that we kept going. We've worked on lots and lots of projects. A little bit different turn of events for Sean, though. We started with a partner network, and up until recently, we really continued that kind of that mentality, even for small projects, just because we let the experts be the experts until some of the equipment got cheap enough where it made sense for our small projects teams to kind of incorporate it and really kind of go that path of learning our own workflows for registration. So it's a little bit different mentality, but works great for us as an engineering service provider in the industrial sector. So a lot of our examples will be in industrial. Spoke at a lot of conferences. Hopefully I bumped into a lot of you virtually or in-person conferences over the years, and look forward to continuing the education path for everybody.
Awesome.
And I've presented with all these folks at some point or time, so I'm happy to band back together.
There you go. And it's exciting to get on and do something like this with you guys, being that we know this year not a lot of people are meeting in person at conferences. So thank you guys for joining us, as well as you attendees. So my name is Matthew Bird. For those of you who haven't talked with me already or been on the last 2 webinars, I'll keep my introduction short. I grew up in the land surveying world, out pounding nails, running total stations and GPS, and learned about scanning in about 2010. And the day we got into scanning was the day I only focused on scanning. My entire shift was away from pursuing, traditional survey, and man, how do we start leveraging technology to different industries and helping solve problems? So for the past several years, my whole focus has been implementation of reality capture through every industry. I was actually just thinking about this yesterday. The diversity of projects we've worked on over the years is ridiculous. From boats to underground mines to forensics to industrial, inside nuclear containments, on oil and gas facilities, roadways. It's really opened our eyes to see the amount of use case for these new technologies, if done properly, if controlled properly, if used the right technology, if you know how to process it. So many steps, and that's why we're excited about these webinars, is to try to keep pushing that education, which is also the goal of our podcast, which is the co-sponsor with this, is the Reality Capture Network. You can also check us out there for continued conversations like this with these types of guests. So, and Kelly, on to you.
Well, yeah, I think most of the people, probably because they got the emails, have heard from me before, so I'll be quick. Been working on the professional side for about 10 years before becoming a software vendor. So I've joined the dark side, and this is the newest thing in my life right now. So If I start running across the room while we're in the middle of the webinar, it's probably because this guy's about to do something on the floor. Don't worry, I'll mute myself.
Uh-oh.
I think
Your dog closed our PowerPoint.
The dog broke the slides.
The dog actually hit the keyboard, and there's apparently a magic shortcut in PowerPoint that will literally make the screen go blank. So I kind of wonder what that is. That's a cool tip right there. I don't know what it is.
That's a better headshot, by the way, than the one you had previously. No offense.
Oh yeah, no, totally. No complaints there. You know, that's why I put him up on camera. He's a lot cuter. All right, I'm gonna let him go. Yeah, chew something. Probably the couch. Yeah. So.
Alrighty.
Come for the learning, stay for the puppy.
And again, just a reminder throughout the webinar, our biggest goals with these is to continue to help answer specific questions. You know, again, we have different backgrounds. We work in different industries. Our goal is education with these. So please submit your questions throughout because we're keeping this very open. We do have a lot of slides and examples, but we're jumping around to different topics based on where our conversations go. So some of your questions will also help guide some of that as well.
Yeah, absolutely. And we're going to kind of kick off in a sequence here. We're just going to start with some data acquisition stuff. One of the topics that came up last time, we had a bunch of questions about combining different data sets together. And Mark had this fun one, which didn't come up before. So I figured, Mark, you might want to just give us a couple words about what the heck this is.
Yeah, so you're looking at kind of a flying elevation view, directly looking at the ground. Maybe you're standing on top of a shed. This is inside the fence line of a transmission, so switch gear and such. Particular reason for doing a multi-instrument workflow and data acquisition on this was we were basically doing some site hardening techniques, basically, you know, more fortressing of the actual transmission gear. And we had to know where all the undergrounds were, because as you can imagine, infrastructure has been around in America for some time. Some of it's well documented, and some of it's, because it's old, switching multiple hands of owners, the documentation's gone. So what we did in this particular project was once we understood the scope of it, we hired a surveyor. The surveyor went out there, occupied the actual state plane coordinate system, then handed off the control to the ground penetrating radar team. They came in and occupied again that exact coordinate system, went in and did their findings. You can see the paint markings, the red and white, or the red, it looks like two lines and a dot going from the right hand side of the screen towards the equipment. Then you see red spray paint going from there to the left. You also see some orange spray paint, some green. And the laser scan, and why we did it in this particular phase was, again, the surveyor set the control, the GPR went out there and laid out their underground findings with spray paint. And there's different levels of accuracy depending on the substrate, you know, as well as the different instruments, not getting into that. And then we went in and had the laser scanning done as the final step, because it memorialized everything in one, let's call it deliverable, even though there's separate deliverables for different applications, but everything was on coordinates, everything was documented. You can go into the laser scan and see exactly where the paint markings were for the undergrounds. And then you can pull up the report and see, okay, 2 feet underground, there was this particular utility, or it understood to be that basic, that potentially that utility, and we could then model that up in our we were using Autodesk InfraWorks and Civil 3D to do the underground modeling from there.
Well, and I love this because this is, you know, the challenge when you have multiple you know, instruments that you're using, whether it's, you know, a drone and a scanner, whether it's a mobile scanner and a scanner, it doesn't matter. The yes. Challenge is always getting the two things to line up. And like if you're using a drone, the best thing to do is if you can scan while your ground control points are on the ground, so the ground control points are in the scan, and so there's like just all sorts of little things like that. But I just love this because it's like, oh look, you know, I don't necessarily even need too much detail on the deliverable. Everything's painted on the ground. It's in the laser scan, which I thought was fantastic. I do want to point out that you can tell I've been working as a software vendor for years because I completely unconsciously typed GDPR instead of GPR.
Yeah.
I reserve the right to make changes to the slides during the presentation, clearly.
There you go.
You're the man.
So I think
hey, if it works, it works.
One thing to point out there when we're talking about multiple technologies in the field, mixing something like underground, mixing drone data into it, different types of laser scanners, is the only way for that to be useful is that you are controlling it properly. Otherwise, you're going to have data that's in different areas and people can't measure from one to the other or know exactly what's below and above so there's the importance of the registration and the control, which is going to be a decent part of our webinar today, is looking at that, how we can control and hybrid registrations and processing data. So we've actually already had a couple questions come up around some of that. So
just to add to that, Matt, too, one thing that's not that much more work to do is if you've got somebody out there doing survey control for your terrestrial work, right? It's not a lot of effort for them to run over and put the prism on a ground control point, take those coordinates and kick it back to you. That way you know with certainty that your laser scanning references and your photogrammetry, drone work, GCPs, they all are talking the same language. There should be no issues in terms of relating those two data sets.
Yeah. And in fact, really expanding on that same thing, if you're already doing control, for scanning, and the crew's already there, we even then go take supplemental shots. So one of the examples we'll show later on a project I registered last night. Instead of only shooting your control in, do some additional shots all the way around your site so that you can use that as a quick check against the point cloud and make sure, hey, yes, that it's lining up here and here, Yep. Yeah. Check shots are always nice.
Absolutely. And there's one other tip that I've heard that I thought was really good, because one of the challenges with mobile data or photogrammetry data is kind of of those aren't as tight as something like terrestrial scanning or your survey control. If you don't have a good control network to tie into, one of the things you can do is do your photogrammetry or your mobile scanning in small contained chunks. This works also great with Matterport data. If you want to mix Matterport data and terrestrial scan data, do a room at a time with Matterport or a mobile scanner or whatever. And then it's easy to take that room, because it won't drift in a room. It's easy to take that, register it to the scan data, and then you don't have that compounded error that then makes it impossible to actually get the two things to line up. So that's another really good pro tip. If you want to mix stuff, just anything that's less accurate, take small chunks and make sure you've kind of got a spine of your terrestrial scan data to tie it into. So
absolutely.
All right, let's, I don't really see anything coming in. Oh, actually, here's a GPR question. Any GPRs you have had success with and would recommend? So Mark, why don't you take it?
We've used a lot of times for, especially in the utility sub mapping of like these sites like this, as well as even in industrial sites for rebar, we've used a company called GPRS. They are a nationwide company. I think they even might have some offices in Mexico and Canada. I could be wrong in that, but they have a wide cast network across the coast. They've done great work for us, and they're good price too. I mean, they're fast, they're efficient, they know what they're doing. But again, like anything else, it's all about planning. So if you don't do a high level of planning before engaging them, you're only going to get what you put into your plan. So this was a very meticulous, we worked with the client, we worked with a lot of other individuals. This was something we did over 50 plus sites across the country for our particular client. And, we had meetings upon meetings to get this the right sequence and timing, and then also working with site safety and all this other stuff. So there's a lot of work that does go into the successful implementation.
Yeah, and for anybody that hasn't worked with ground penetrating radar before, just note of caution, it's a wonderful tool, but it's not perfect, and you will do a lot of connecting of dots trying to figure stuff out, because we had a project, the moisture content of the soil has a huge impact on its accuracy and what it can detect. Like, we coordinated with the client, and they were supposed to have all the sprinklers turned off. Well, there was one area which happened to be the most critical area where they forgot to do it, and the crew went out and didn't find anything there because, of course, the ground had been like soaked wet 2 days before. And then we started digging in that area, and there's a bunch of stuff that was there. Everybody was upset, and we were like, yeah, it's your sprinkler 2 days before, not our fault, buddy.
And that's just it comes back to the same point, whether it's above ground or below ground. There's a lot of different tools, and they all have different times that they're better or worse. You know, just like GPR is just a underground tool, you know, then you've got equipment that hooks directly up to lines and electric, you know, you can do the locating, you've got the metal detectors, you kind of use a mix of tools. And it's the same for the above ground. You know, you don't just pick one scanner and it's the only scanner for every scenario. There are some that you can get by with, but there's, you know, there's better or worse depending on the industry, depending on the accuracy needs. So again, when you guys, those of you that are new and looking to get into it, that's still our biggest suggestion. Same from the other webinars, is make sure you consult with people on your needs, your use case, your industry type, your accuracy needs before picking a type of equipment to run with.
And just to tack onto that, Matt, I think it's really important too to manage the expectations of your clients, right? Like some of your clients think that you need this 1 millimeter, 2 millimeter super accurate model, and sometimes it's just not the case too. So it can go the other way too, where it's like you may have overkill for what, you know, is the actual needs of your clients. Find the right tool for the job.
Yeah, and that comes back to just the communication. One of the biggest things I think about this technology, and it's why it's lacking in adoption, and there's still a lot of room, is just the communication side of the tool, like you said, of the accuracy, of the deliverable, of the actual need, and making sure all the parties are involved up front in that discussion.
All right, guys, let's jump to some pre-processing conversation. I know I snagged this image from Sean, actually. So Sean, you want to tell us a little bit about what happened here?
Yeah, so I think one of the key items for this entire presentation is like when things go wrong, or figuring out when something breaks and things like that. And this is obviously a targeted solution, a targeted example, but I think it's really important, a really key part of our process when we start a project. We go out and we do 100, 200 scans, whatever it is, and we get back to the office. I think it's really important to kind of clean out some of the mess. And I know Matt's going to talk a little bit about a project he had where he was kind of duplicating rooms and they were stacking on top of each other because they were so like-minded, like a hotel or an apartment style building. And I think really that like a lot of people don't take just an hour. You know, when you get back to the office and you throw the data into your registration software and you've done that pre-process, you've found all your targets and whatnot, I think it's really important to make sure you go through each scan and scrub that data. So for us, that process is removing bad targets, something that maybe we didn't put enough points on, or it didn't get picked up in the software. You know, making sure that all your targets are there, and that when you go to hit start on that registration process, it's going to come together the way you intended it for it to come together. And then reflection, right? There's so many things out there in the built environment that just give you bad points. So whether you're doing a cloud-to-cloud registration or you're trying to QA/QC your registration on a targeted registration, you know, something like a mirror, like you can see on the left side there, taking 2 seconds to kind of clip out those points so that you're not getting the room twice can really make your data look a lot cleaner. And especially when you start to move to modeling, you know, it's a little less confusing what you're looking at when you're not seeing the room mirrored on itself, right? So I think it's really important, it's really crucial that as part of that kind of pre-processing process that you do go through and you kind of clean through your scans, make sure you have all your targets. Because if you take an hour at the beginning, it might save you 4 to 6 hours later on when you can't figure out why it went wrong.
Or even more when you've actually already started modeling off of the scans and then realize you have a 2-inch bust.
Exactly.
The cloud algorithm saw the reflected wall and pulled it to something. And it just,
now you're going back and fixing it. You're re-exporting, you're re-indexing scans, you're regrouping scans, like you're duplicating your efforts. That's really where the project goes wrong, right? It's when you have to rework something.
Yeah, and for me, this is the number one reason why I see people having to do rework is they don't do this step before doing their registration. If they're doing cloud to cloud, they just miss errors that cause either this or through glass buildings across the street.
Curtain wall.
Right?
Yep.
Yeah, people don't anticipate that, and that's literally like for people that use Recap. And we had a question come in. Somebody was like, should I use Recap or Scene? You know, they all got very similar cloud-to-cloud registration algorithms, but the biggest difference between Recap and every other registration tool on the market is every other registration tool on the market, to my knowledge, will let you clean your scans before you register them, and Recap won't. And that's the reason not to use Recap, right there. If you
can I do a screen share, Kelly?
Please, let me kill mine and make you presenter here.
See if that'll work.
You
I was gonna say, another reason not to use recap is just there's a lot of, I mean, the strength of, you can do visual alignment, 2D, all
Yes.
those other things. It's so much harder to do in recap and make it work, right? For all of us seasoned recap, we tried it. We all tried it. It just was painful.
Yep. Okay.
It's a good thing in theory.
Are you able to see a screen yet?
Yes.
We are.
Yeah.
All right. Do you see the recap project, or do you see all the other stuff?
I see your desktop.
I see a desktop in Windows Explorer.
I see a shameless plug for Clear Edge products.
Uh-oh. Let me make sure I'm getting the right screen here.
Oh, we did see recap for a second. There it is.
Okay, do you see it now?
Yep.
Okay, perfect. So you can see the floor plan of this project, right?
Yes.
Yes.
So this was a project we ended up helping someone register. We didn't actually do the capture, but it was done with no targets. And you can see the repetitive nature of these rooms.
Mm-hmm.
Every room has the same layout of beds, the same doorways, and then it has a bathroom with a mirror, and it has mirrors in the room. So when we first dumped these scans in to actually do the registration, everywhere there's a mirror, it's duplicating the room. So there were 2 extra walls, there were extra bathrooms for every single data set. So before using cloud to cloud to register this, we would have to walk through each of those scans and jump in that bubble view and clean out the mirrors. Because if you expect that cloud to cloud just means you scan and dump it in and hit register, you're going to run into a nightmare. You're going to have these rooms are going to be stacked on top of each other because they thought it was the same room. You're going to have duplicate walls. So especially in repetitive type projects is where you have to be more specific and more critical about notes in the field. Even if you're going to cloud to cloud a project like this, doing a scan map so you know, hey, down this hallway and the rooms right here are scan numbers 1 through 20. Okay, now when I get in and register that, I can break those out separately, and I know that that's those rooms. And then scan 20 to 40 is down at the bottom. I can break those out. So if it's repetitive and if you're cloud to cloud, then you're going to want to really track your scan locations and think about the cleanup if you're noticing mirrors and things. And then even one more step beyond that, if you're the one registering it and you did it in the field, that makes it easier. You know what to expect. If you're handing off the data to someone else, make sure that you kind of think about those things. And this is something for whether it's you capturing or your team capturing, making field notes about, was there reflective surfaces? Were there mirrors I need to be worried about? Are there critical areas you put targets up? Having all that information before just getting handed scans to register makes the process way smoother.
Totally. And this is yet another plug for hybrid registrations, right? Because if you hang a couple paper targets in those rooms and you take 30 minutes or an hour to quickly recognize them and note them, then a lot of those problems go away because the targets will feed into the constraint solver, and then all of a sudden the rooms won't be able to overlap. And so, this is again targets or survey control, and again always use 3 because this, I was involved in a project where they scanned a huge NFL stadium, like thousands and thousands and thousands. I think there were like 10,000 scans on this project. And they did everything right in the sense that they had some targets, they had some survey control, and they had their scans. But there's this bad habit to only trust one of them above all others, and usually that's survey control because we all assume survey control is the most accurate. But this really funny thing happened. A part of the group that was going out and capturing this, they would have their spheres on a prism pole that had a little level in it, and they were setting it on the control points and then doing their scans. But they had not calibrated the level in the prism pole in 8 years. And so what happened is when they did all the registration, they were up to 2 inches off. Just in terms of the levelness of the pole being so badly calibrated, and just depending on who set up the pole where, of course, it's 2 inches off in any direction.
Yeah.
So they kept overweighting the which, by the way, pro tip, The more advanced registration tools, you can change the weight of constraints. So you can have something like a survey control have a higher weight, which means it's stronger than your cloud to cloud or vice versa. And, and actually, I think, Sean, why don't you share your screen, because you had a great registration example.
Sure.
So let me make you a presenter real quick. But like, you can change the weights of these things, and that will change how the registration lines up. So on that job, they had to go in and de-weight the survey control substantially,
Yeah.
and rely a lot more on cloud to cloud, because which is dangerous in a large project, but because that was the only thing they could do, because the survey controls.
Yeah, so
the
you guys
fine,
see,
controls are bad.
sorry, you guys seeing scene on my screen?
Yep.
The insane.
Awesome. So just to sort of like to kind of put a bow on what you were talking about, Kelly, and you mentioned this a little bit earlier too, right? Like, it's really important to kind of understand the control aspect of the project. And so, you know, there's nothing wrong with a cloud to cloud registration if you know how to integrate that and make sure that's accurate, right? So like, this is just a really high level quick example, but those hybrid registrations, those are things that we like to do for speed and efficiency, right? So this is just a project, and I'll just quickly show you kind of a planar scan, right? Like, this is a TI fit out that we did in downtown Boston. You'll notice on the outside at the windows that there's a lot of ribbon windows, right? And so it's also under construction, so the ceilings are out. So a lot of those planes that are in multiple directions are kind of missing. And you're obviously not gonna want to do a cloud to cloud registration with a lot of, you know, like reflective duct with insulation and whatnot. So one of the things that we'll do is kind of a hybrid registration. So if you look at this scan here, if I turn around, there's no targets going that way, right? And if I go to this scan here, there's targets going this way, and it's here on the end, but the next scan in the corner, there's no targets going this way. So one thing that we'll do for kind of speed and efficiency to kind of speed up the field process is have a targeted control backbone, right? So, you know, these two clusters, which are already registered together, have targets all the way around, and that's in the areas where maybe the ceilings are missing, or there's a lot of curtain wall or punched openings, a lot of reflective surfaces. You know, we'll tend to do that with a targeted traverse, but this kind of core area that's away from the middle space, you know, having that hybrid registration where you have a, you know, cluster that has a scan that's kind of the start into your hybrid registration, where there's no targets going forward, but you have targets behind. Once you kind of have the, you know, that cloud to cloud cluster targeted and registered, one thing that's really easy to do is, once you've got that cluster, if you have kind of control scans, like Matt mentioned, right? Scans that are really important, mark down the number and understand, hey, this is the start of where we changed our process. You know, one thing that we like to do, and this obviously the cloud to cloud clusters have been put together for speed, but by having targeted scans at the end of both of those clusters, it's very easy once it's set to take two clusters that are on control and target register a cloud to cloud cluster back into the overall project, right? So this may take a minute because I'm not on my nice beefy work computer, but boom, right? Snaps into place. You can check your target tensions and make sure you're happy with the target tensions. I'm pretty happy with those. And so, you know, we were able to take, you know, 6,000 square feet of space and do it in 25 minutes in a target list setting, as opposed to maybe 35 or 40 minutes. And so I'll just show one other example of something that we like to do as we're kind of in a tips and tricks thing. You know, a large book of our work is renovation work in occupied spaces with ceilings, right? And so, you know, you capture a scan below the ceiling, you have all your targets in it. When you're doing kind of an above ceiling thing, right? If I do this registration, I get a scan at the tile, I can see my targets, but I'm having a hard time seeing over this insulation, for instance, right? So I can do a higher scan. We call this kind of a high-low as part of our process. We can crank this scan up higher into the ceiling, try to get more of the mechanical systems, and then it's about paring them down. And Kelly, you mentioned earlier, it's good to work at like a local level, right? So if I take, you know, scan 37 right here at the tile and scan 38, and I cloud to cloud register those in one cluster, that accuracy at a local level is really, really high, right? But now that I have 37 and 38 and they're joined together in a cloud to cloud format, I can target register 37 back into the room using targets. And so that kind of hybrid registration, I think, is really important to speed, efficiency, and getting the detail you need. It's kind of thinking outside the box on, you know, how can I group these things and pare these things down so that I have a good local accuracy, and working that inside to out to have a really good project accuracy.
Yep.
I want to highlight that right there is just a good ceiling tile workflow period. What you just did, the tile level scan plus one right above it, like I see people missing that tile level all the time, and then you're trying to register the two together.
Mm-hmm.
Yeah, if you don't have it, you sorry, if you don't have that, you're screwed sometimes,
Yeah.
right? Like if if you can't force two things to coexist that don't have the overlap. So it's really
I will
important.
say,
Go ahead.
there is still the hope.
There is the hope.
If
Just a sliver. You just need a little bit.
If you miss that, you don't get, now you're past targeted registration, you're past cloud to cloud registration. Now you're down to, okay, the only way to get this data in place is to manually transform it and get it aligned as best as possible. Look for a little feature that you might see some data and manually get it close, lock that in place, and now tie it back down. Not the ideal scenario, but people still do run into that. They're like, they don't even know how to do that step. So that's why
one thing that I think is amazing is, like, one thing, and like one of the biggest takeaways I hope from this as we kind of talk through this, I think the biggest takeaway is take like 5 extra minutes all the time, and it will save you hours on the backside, right? It'll save you hours of headaches. So to run one extra scan just at the tile, and then even if it's only 1.5 feet higher, right? Another 2-minute scan or a 3-minute scan, depending on what equipment you're using, can save you a world of hurt at the end of the day.
And do the lowest res scan for that joiner scan, right? Because people get used to just hitting the same button. But like I always tell people, same thing for doorways. Anytime you go into a room, you do the scan in the hallway, do a scan in the doorway, and then a scan inside the doorway in the room, and that just gets rid of so many problems. They're like, yeah, but that adds 3 minutes.
Yeah.
Like, no, you do it at the fastest resolution that scanner can handle with no photographs. It takes 45 or 30 seconds. Because remember, cloud-to-cloud registration algorithms, they don't use all the points in the scan anyway. They super estimate. So it's like you don't lose any accuracy on registration, but that 30-second scan or 15-second scan just makes life so much better afterwards. So
it's funny when you think about it too, because that 30 or 40-second scan still has over 1 million dimensionable points, right? Like we're thinking like, oh, we're not going to get enough point coverage. You're still getting 1 million dimensionable points in that quick scan, right? So it doesn't have to be high and a 5-minute long distance outdoor scan in order to make those connections.
Kelly, while we're on the hybrid, do you have those couple slides that we could pull open?
Absolutely. Yeah, let me snap to that, and I will share my screen again.
And they should be numbered in order.
I put them in order as they were in the email, so hopefully I didn't mess it up. All right.
Well, we'll see.
Yeah. All right. So show my screen. Yes. Right now, please. Yeah. Okay. Lovely. Lovely.
Yep. Unfortunately, they're not in order, but that's okay.
Well, tell me what they're the order they were in the email. That was the best I could do. So where do you want me to start, sir?
They should be named 1, 2, 3, 4, 5, 6, 7. Can we go to number 1?
They are not named at all.
Okay. Well, we'll just go with what's on the screen then. So talking about the hybrid process, we were just looking at Sean's great example inside of a building. This is an example I actually was registering last night, and this is the exterior of a site. And there were quite a few complications here because it's a very active, busy location, lots of vehicles coming in and out. And so originally we said, oh, and here's an example of some of the vehicles.
Oh my God.
Isn't that beautiful? So for one, while we're on this slide, I'll say, for those of you who haven't seen this, this is an example of when you do a scan and a truck drives by, and then you do another scan and another truck drives by. By the time you have 50 scans down this roadway here, you have trucks all over the place, pieces of them, things have moved. So it becomes very messy. Let's check another slide.
And that won't mess up your cloud-to-cloud registration at all. Do you want to
practice with surveyors? Yeah.
Other one?
Just add a comment on that, Matt.
There we go. So the way we controlled and processed this, you can see 4 different colors here, right? So we split up the scans on each end of the building. Now, mind you, the length of that horizontally right there is about a 900-foot long building. And we did not use spheres or checkerboards along the edges of these buildings. We used cloud to cloud, which is a long length to not have many control between scans, but it's still possible. Go back to the first scan I did, or the first screenshot. So you can see the yellow highlighted data in the point cloud. Those are the selected scans that have 4 to 5 checkerboard targets per scan. And those checkerboards we put up, we shot in with our survey control. So we have known XYZ coordinates on those checkerboards on each corner of the building. Now, when we break up those clusters, go back to the last image if you would. Now, when we break up those clusters right there, I can register all one side of the building together with cloud to cloud, and I can constrain it with those 2 end scans that have the known control points to place it properly, horizontally, vertically. It will place properly based on the survey. And then I can do that on each end of the building. If I did not use survey, which I was actually waiting on the control, so I registered it prior to survey. If I register these 4 clusters individually without survey control and try to fit them together, each of them miss by 6 or 7 inches. So if you don't integrate the survey control process in something this size and you're using cloud to cloud, you're gonna have issues, period. You really can't get away from it.
We had a good question come in where somebody, and this is you know, since it's an advanced class, just use NavViz mobile scanning, and then no registration is required. And I'm like, mobile scanners drift, terrestrial scanners drift, every scanner drifts.
Drift.
Worse for mobile than terrestrial. And this is a great example. A terrestrial scanner drifting 6 inches over 900 feet. Mobile's worse. So like,
yeah,
absolutely.
Survey control can drift.
Yeah, and you know,
Right.
and
We have an example coming up.
There's times that you got to check. So even our survey on things like this, we have to make sure that our survey is accurate. Otherwise, this process won't even work. And here's an example real quick. This is in the panoramic view of one of the controlled scans. You can see we've got checkerboards here, and there's a couple on the back side of this as well. So they're all the way balanced around the scanner, and you can see you know, each point number there is the survey number. So we've got it matched in the scan control, and we've got it matched in the scan itself. And then that helps us tie those down. So if you're ever trying to, you know, you're limited, we wanted to use targets around the building, spheres, just because it helps. It's easier to register it that way. But because of the amount of traffic, we could not keep them out with the trucks. So we really were bound to kind of shift and do this type of workflow. And it came out well. Overall accuracies of that project was about 0.02 of a foot. So pretty tight for that big of a site.
Yeah, that's great. Sean, I do want to jump to modeling, but this was the example.
We can if you want. Yeah.
No, just do it. Give us a quick one on this, because as you said, survey control drifts.
So even survey control can drift, and this is actually well timed with mat slides, because we did almost a 1/4 mile length of train track for the T, in which we were having a heck of a time getting all of our data to actually register and compare, and getting, as you can see in the image, some super high target tensions, right? And so, you know, we were working with the survey to say, hey, like something's, you know, not adding up. You know, we were able to constrain one end, but when we went to the other end, we were getting 3-4 inch issues with the control. And so that drift can happen even with the survey control. And that can be a number of things. And it's really important to like be able to adapt and figure out, okay, well, this isn't working. How are we going to solve this issue? And so on this project in particular, you know, we ended up having to work with them and go out and resurvey. And then we brought in some of our bond surveyors and try to figure out, why are we having a 4-inch issue across this entire length? And it came down to least squares adjustments, right? So, you know, survey was kind of balancing and calculating points and trying to kind of best fit taking some of their error and distributing it across the entire data. We were able to kind of go back out and work through it. So it's you know, I think Matt's got a good point. Is even sometimes when you have that constraints on both ends, you can still have a little bit of drift. It's important to get that control distributed evenly throughout the project.
Well, and one more thing I want to bring up on that note, like one of the questions is, can you identify common points between scans? And it kind of makes me think, okay, even in this process we're talking about, so that example I had along those ends of the building, when I registered those 4 sides of the building individually, using cloud to cloud, they all had green lights. They said they were within a 100th of a foot. But when you try to put them together is where you notice they're actually 6-7 inches off from one end to the other. So if you don't have the known points on each end, that's where your issue is going to come up. If you're registering over a long area or complex area, you have to actually have those known points on the end. Otherwise, your data will tell you it's registered, but it's actually like bowing. And by the time you have that accumulated error in 4 different clusters and they try to meet on each end, it just doesn't work.
Yeah.
Absolutely.
That image is just is in conjunction, Kelly. So you can see, obviously, right? Like there's our control targets. We've even tried to manually name them and force that constraint, and that nope, yeah. And so it's important. You need to do that review. It's really important to check those tensions too, to make sure you don't have something funny going on with your control background. You know, the backbone there.
And this is why hybrid registrations are so important, because like I've caught so many control busts because I also ran cloud to cloud, or I've caught so many cloud to cloud busts because I had targets. And it's like, these are mechanisms to make sure you're doing a good job. But let's jump into modeling, otherwise we won't get to it. Goodness gracious. Sean, I'll just hand it back to you because you sent in this lovely vehicle right here.
Sure. So I know we're going to get to Greg's slides too. Greg Hale had some slides from the 201 section that have been kind of thrown in here too. But you know, modeling, right? There's 2 trains of thought here. You can model everything and create an existing conditions model, which can be really beneficial in the right application. But I think also too, we're going to cover just really quickly, you don't need to always model everything. So there's not a one size fits all to each project. So just like there's the technology, the hardware that you're using in the field is not a one size fits all approach. There's 2 ways that you can really approach the modeling process. And so these are just a couple of examples of, going in and tracing over the point clouds. Sometimes that's an automated process, whether it's clear, edgewise or otherwise. And sometimes it's tracing in Revit or Civil 3D or whatever, Plant 3D, whatever your preferred platform is. But I think it's really important too, and especially when working with your clients, is you have this tremendous accuracy. You're creating this really accurate recreation of the built environment. It's really important to check that too. And when piping is not plumb or when piping is pitched, I think it's important that you're going in and you're actually visualizing and making sure that all those features are in there. So we like to do a very manual process of our QA/QC of our models. It's very much going into Navisworks, overlaying the point cloud, overlaying the model elements, and doing the checks. In some situations, like this is a CHP, so it's a little easier to see. So it's open. You're gonna know when something's not there and is clearly missing, right? But maybe in an above ceiling situation, like I showed in that little demo, it's really important to get in there and understand, hey, have we captured everything here? And you can do that one of 2 ways. You can do that as a manual process, or you can use a software like a Verity or another, sample, or another software that is trying to say, hey, something's here in the point cloud data, but it's not here in the model. Something doesn't jive. And so I think it's important, if you're promising these 1/4 inch, 1/2 inch accurate models, you really got to make sure you're going through, whether you drew it yourself or you extracted it. It still all needs to be very much reviewed and understood that everything's been shown correctly in the model.
Yeah, and I jumped there and showed one of Greg's slides, and we unfortunately didn't get to these in the last one, but yeah, this is just an example of what you can do with Verity. There's things like Cloud Compare that are free, which are great tools for this. There's a couple other things out there that will do some automated analysis, but it really helps, check every object rather than just, doing kind of the spot check and go to walkthrough. But and I think this is another thing in terms of checking accuracy, and this is so hard to communicate to clients, right? Because when you're getting into this problem, it's like, oh my gosh, I've got this scan and it's so perfect, and the clients are expecting super accurate stuff, but they also want straight pipes that are all parallel to each other, or
plumb walls
that are vertical. And it's like, man, that is a huge challenge, helping clients visualize and understand how the model they're getting deviates from the point cloud that was captured, so that they're even though they're getting a model that's somewhat nominalized, they still have some concept of the real built environment, so that they make, you know, intelligent decisions about what they're doing, whether it's a demo or coordinating something. But yeah.
And we talked about that too. Just to circle back on it, right? That communication is so crucial. Like, from you understand what the expectations are of the client, and what's realistic, what's not realistic, what they're looking for. Are they looking for plumb walls? Are they looking for out of plumb walls? And, you know, there's nothing worse than when you get to the end of the job and you modeled everything as it existed in the field, and the architect's like, I can't use this. I like 90-degree angles. I can't dimension anything. So that communication really has to happen up front. It really does.
Yeah, and I love you kind of quickly walked through it, and I don't know if anybody wants to elaborate on this, but there really are kind of three methodology. Wow, that's a triple quote. That's not a thing, is it? There's three methodologies of kind of modeling that you run into, and you mentioned tracing, which is using whatever authoring tool, and you do the best you can to eyeball it and trace. There's manual extraction tools. And this is an area where semantics gets a little tricky, because people will call it automatic extraction. Well, it's automatically extracting one object, but yeah, so there are these tools that will do a statistical analysis of the point cloud data and then fit or find a shape, etc., to that one thing. And so I usually call that manual extraction. You can call it whatever you want. And then there's
assisted modeling tool.
Yes, there we go. Assisted modeling. I love that. And then there are automated extraction tools, which attempt to go through and find all the pipes or all the walls or all the whatever. But all algorithms have failures. So there is no perfect, just like people aren't perfect at this, algorithms aren't perfect at it either. So all of those tools, they get some percentage of those things found for you, which is a great head start. But they're not like the black, the little black magic button where you click it and then, oh, my entire piping model is done. It's like, nah, it
still needs to be reviewed.
Right. Cool. And a lot of the work we do is, I would even call it a fourth area, right? Which is just leave the point cloud as is, model the new scope of work, and we actually go in and edit the point clouds for the demolition scope, where we're removing, and those, if you brought up those slides, Kelly, I mean, we would say we're removing some of those vessels or some of the motors and the piping and saying, okay, here's where we do a tie-in. We cut the point cloud right there. We might model like a 10-foot tieback of the pipe and then go from there. So it just, again, it depends on your deliverables. It depends on your scope of work and really what you're what your design intent and what your contract comes down to. Because if you're doing fabrication, you don't want plumb walls. You don't want everything perfect, because if you're trying to get down to a fabricated curtain wall to go up against that, that wall that's off plumb, you want to make sure all those brackets and all that stuff in there is the right size. Because if you try to fabricate the new curtain wall off of a plumb wall, somebody's going to get in trouble.
Yep.
Somebody's going to get in trouble.
And there's kind of two options there, right? There is, hey, client company that wants that type of information, you have to either be prepared to utilize the point cloud and get through that learning curve, help, get educated on what software can be used to do that process, or two, you have to use a provider that knows how to take that data and create maybe a report for you at certain locations, but not just give in and say, no, we'll just take the model, because then you're gonna use the wrong measurements, get things fabricated wrong, and run into more issues and think the technology doesn't work, when really it just comes back to communication, workflow, and making sure that deliverable was done the proper way.
It's almost never the first one, right? It's almost never that they're going to get in there, get into the nitty gritty and understand what they're looking at. They just want to know what the problem is, really, not how you got there.
Yeah, right.
Unless it is a situation that it's like it's a critical piece of that company's work, like like Mark, they like he said, they've gotten to the point that they're not just relying on outsource. They do a lot of it internally of how to deal with the data and kind of perfecting their internal workflow. And I think that's where a lot of clients can really maximize the benefits of these technologies, is not only relying on complete outsourced 100% from capture to deliverable, is like take the next step in what more can we do with this data that's being captured.
Absolutely.
One thing maybe to tie back, Kelly, if you can open up that one site, shameless plug for my class last year at AU, but it shows you some recap editing techniques, but the video, I think, is a, I put myself in a lot of people's shoes. They're either just getting into this or somebody's handing them a laser scan data set. Maybe they're oops, we're on the 17-minute mark.
Oh, well, I'll get you there eventually.
Yeah, no, we don't want to watch this whole thing.
Yeah, I'm trying to get to the progress bar. 17 minutes. Here
There
we go.
Perfect, right there. If you just hit pause, or actually let it play out. I'll kind of talk through this. I mean, this is where bad control methods with scanning, where they actually applied survey control, but they applied the survey control constraints to be heavily weighted to every single scan position. What you'll see in this particular scan set is this is just a curve that we're looking at in an industrial area. And when you zoom in and recap, this is a quality check that anybody can do. If you have recap, all you have to do is turn on your scans, turn it into color mode, and then just do a very thin like slice. Maybe think of it like an inch thick limit box. And if you see offsets of any object when you're only doing 1 inch thickness, and you see this many offsets,
you got a
bad
problem.
registration.
Yeah.
Right. I mean, that's just bad registration. That's 5 curbs in 1 inch thick slice. And that's only 12 scan positions, by the way. So if you're seeing 5 different scan positions out of 12, that's not good.
Well, and that you said this is a process where they were shooting survey control in every scan setup.
Yes, and they were applying it to every scan setup as opposed to doing cloud to cloud, right? Localizing it and then trying to distribute the cloud to cloud or whatever the weighted constraints were. It then pulled all of the scan positions away from each other, right? Because they didn't know what survey control spot was bad.
Yeah, and
know which one was.
And we've seen that in different industries have been trained in a way of like, this is the method to be used. You talk about big industrial refineries, they have certain requirements sometimes that say you need 5 survey shots in every single scan setup. And it's like, the technology is past that at this point. That's way more laborious, way more expensive, way less accurate. But until they're educated on what the other option is, they think that's the only way and it's the best way, when it's not. If you cloud to cloud those together and then place them on survey and break it up and you use these methods we're talking about, you're going faster, more accurate, cheaper, better data.
In a weird way.
Actually, quick as well. Let me just jump in super fast. Weighting constraints is a great way to troubleshoot your registrations too, because in something like this, what they should have done is they should have gone through and picked each control point and basically de-weighted or disabled it, and then rerun the bundle optimization. And what that will do is then rerun everything without that one control point. And then you look and see, you can either look at your error numbers, or you can actually do kind of some slices in something like Cyclone or whatever you're using and be like, oh, things got a lot better, or that didn't change anything. And then you do the next one, de-weight it, reweight, de-weight, reweight. And if you'll run that through, it sounds tedious, but it doesn't take that long. It's like 10 minutes. And you will find the one that's bad, you can turn that one off, and life gets a lot better. But so you can use the weighting or the disabling to really troubleshoot those things. So that's a really important thing to know how to do.
All right,
I was just going to add.
When you're done, we'll take a question.
Sure, I was just going to add, in a weird way too, like when you over constrain something like that, aren't you just making more opportunities to make a mistake at the end of the day? It's more likely you're going to have an issue. That's all I was going to add to that.
Absolutely. Just want to make sure, like in this case, a lot of people still receive laser scan data sets by hard drive or whatever it may be, and you see that. Don't not use the data, but try to figure out who did the scanning, because a lot of people still don't have seen Cyclone, whatever, right? RealWorks. So again, doing it in recap isn't going to be easy. I mean, if you do figure out, hopefully you can fix it in recap, but it will be a challenge sometimes. So always try to find who the vendor is, work with them and say, hey, look, we found this error. This is really critical to our project success. you have to fix this. Sometimes you're just going to run into a wall and that won't happen. So
yeah, and
any of us here to help you.
yeah,
right?
I was gonna say not a shameless plug, but you know, a lot of times if a vendor has handed over data to you and that's what it looks like, you're almost not you might not be best off going back to them to fix it if they messed it up in the first place. They may not know the process to fix it, so you might be better off going to a service provider that is open to helping you. You know, we help people fix registration problems all the time. We're not afraid to help other people's data or worry about who captured it, or, oh, we don't want to help them because you're going to go back again. You know, there are people that will help you because the same reason all four of us are on here, we want to see people succeed. We want to see the technology be believed in. So, you know, be open to that. But we have a lot of questions coming in. I just want to throw a couple in real quick. One, we were talking about the modeling process and accuracies and things like that. Here's a question. In a scan to BIM model, is the LOA value acceptable to all elements in the model? So when you're doing a model from scan to BIM, are you holding that to all elements? Do you consult with the client? What do you say, Sean?
I'll jump in on that one. So we define it. Our proposal is annoyingly long, right? When we send a proposal to a client, it's like 22 pages. It's annoyingly long, but there's an element by element list. What's included in the model, what is not included in the model, and if there's anything beyond the ordinary, what LOD we expect to provide that to you. And so what it does is it allows your client to take a look at it and say, well, okay, I see we're going to get LOD 200 piping, but we want LOD 400 equipment. We want to understand the face of the controls and what each panel does and whatnot. And so that's going to dictate the price when you get to the end of the proposal, right? So, it's very important to spell that out item by item, what the expectations are, and let your client come back and say, hey, we kind of want a little extra detail on this, or, we don't quite need that accurate of the walls, right? Like, instead of an LOD 350 wall, we just want an LOD 200 wall. Just give it to me plumb where it roughly is in space, and it has this accuracy. And I think it's just important to spell that out in your proposals.
Yeah. And I guess I think it just repeats the same thing we say over and over and over and over is communication. I honestly often tell people, like, at this point, I've had so many conversations, I almost prefer to not use an LOD or an LOA because people sometimes don't even understand those in depth enough. It's better to walk through all the different trades, all the different elements, talk about the use of the project, talk about the accuracy need for certain pieces, and really build that out in the agreement. And if it's around an LOD or an LOA, you can put those in the agreement if you want, but really get specific.
We use it just to formalize.
Yeah, they're a great way to document stuff in the proposal. But in terms, I mean, the customers, the clients, the people that,
and
that's for us, right?
Yeah.
And I do want to do one thing real quick because we are at time or 3 minutes past it, and just say that we are going to stick on for another 30 minutes, probably 20, 30 minutes, something like that, and try and answer as many questions as we can. So if you're watching, you are welcome to stick around and participate, and you have more questions, throw them up. We'll do the best we can to get to them. But if you've got a hard stop and you need to bail, it's all being recorded. We are going to send out the recorded session about a week or so afterwards. And Matt and I usually do a Q&A session the week after as well, just to kind of get any questions that didn't get answered. And that all gets posted on LinkedIn. There's links in the LinkedIn group. And please, reach out to anybody on the panel through the LinkedIn group, LinkedIn, Twitter, whatever floats your boat. But thank you for those of you that have to hop off. Thank you so much for coming. I hope it was worth your time. I hope you really enjoyed it. And I will shut up and we can get back to actually answering questions. But just wanted to give an outro there. So
we've even with people jumping off, we've still got 200 people hanging around to hear some Q&A. So we'll still try to answer some questions.
Yeah, let's get back to it. Sorry to interrupt.
No, you're good. So I think we just ended on saying, when it comes to scan to BIM, when it comes to elements and expectations, it's just communicate clearly and really dig into the details on each type of portion of the model, the accuracy need, the use case, et cetera, as opposed to blanketing it with a LOD statement.
Yeah, and just one last really quick thing on that.
Right? Just ask the question why to your client. A lot of people are scared of asking that question, but it is a very important question. Why do you want me to model that? And if they can't give you a good reason, it's usually, let's just pause, let's scan it, let's review it, and really find out what you're going to use this for first. Because a lot of times they're like, well, I just need it because I need to be able to do space planning. Well, let's walk through some of the tools, right? I mean, or, you know, I do need to get an exact replica of this particular panel, like Sean just said, right? I need to build this out. I need to have this for some type of virtual training, whatever. Okay, we got to get there. But like everything else, I mean, it's always why. One simple question.
We do have a couple questions pertaining to LOD information and such. Where would you guys recommend people to find information on LOD and LOA?
So shameless plug for Kelly. You know, the USIBD is a phenomenal resource. You know, it's not that old. It's only been around a few years, but I think the last few years they've really ramped that up and become a really good resource for people when it comes to LOA. And then we referenced the BIM form LOD spec in our proposal. You know, it stays pretty relatively the same. We use kind of our own interpreted definition of what each LOD is, so it's a little clearer to the client, and it kind of brings it down to a, you know, more of a boots on the ground level of what that is. But I think those two, BIM Forum and USIBD, are kind of the gold standard in terms of those references.
And that's www.usibd.org. And I will say becoming a member is like dirt stinking cheap, but it gets you access to their RFP templates, all this other stuff. It's like 200 something bucks a year, and most firms will either pay for it or match or whatever. Like super cheap, super easy resource, great community. So please, 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 if you hadn't heard of it before, check it out and join if you can, because if you're in this world, and particularly if you're getting started, oh my God, it can make your life so much easier.
Yeah, we've gotten this question in all the sessions, and it'd be good to hear just Sean and Mark separately based on the types of projects you do. When do you recommend using color when scanning as opposed to black and white?
I'll let you start, Mark.
Geez, a lot of what we do is industrial, right? So that heavily weighs based on how good the lighting is in the facility. Some facilities get very, very dark, so black and white is forced. We do prefer color, knowing that some units does obviously affect a much higher scan time, especially when we third party, because a lot of the work we do is they're going P-Series Leica because of survey traverse, because it's a long site. So being able to do traversing while scanning is a very significant time saver in the field. But if there's a heavy amount of demolition, and we're talking it's an active facility like an automotive plant, and we're only going in there because we're trying to document maybe a chilled water chase over 2,000 feet long, black and white all day long. It really depends on, again, that conversation and asking why with your client, why we color. So if it's a lot of gut renovation work, it's going to be black and white. But a lot of the chemical facilities we do work in, a lot of the food facilities, even though it's a lot of stainless and stuff like that, we still do color because it's highly visual. There's a lot of tagging and colorization of different utilities, and it makes it very easy for somebody to recognize what system is versus another. Yeah.
And I think that's we'll hear from Sean as well. But I think when you're picking color, sometimes it's a choice, sometimes it's not. Sometimes you have the time you can set up. Sometimes you're restricted. So even though we all love color data, sometimes it's not even a choice. But Sean, what do you think?
Yeah, so I'm going to echo a lot of what Mark just said, but for us, I mean, the bulk of our work is above ceiling addition renovation type projects, whether it's healthcare or it's dorms, school, lab buildings, things like that. And those are almost always black and white for us. It's fast, it's efficient, and the lighting above ceiling is just not conducive to color scanning. But we do a lot of plant work, right? Combined heat and power plants, central heating plants, chiller plants, boiler halls,
Yeah.
things of that nature. And so a lot of that piping is usually color coded, right?
Yeah.
Whether it's tagged color coded or the pipe itself has actually been painted. And so that's a no-brainer for us because you can very quickly pick out systems and things of that nature. And then really any projects that well, selfishly, anything that has a high market about like a high marketing value, we may slip in some extra color scans just for the images and stuff like that. But definitely when materiality comes into play, we're doing a project right now actually at Worcester City Hall. It's like a square footage project. They want to paint. There's elevations. There's wood combined with plaster, combined with marble, and so anywhere where materiality is key and you need to differentiate that, you're not going to get that from a black and white scan like you will with a color scan. So
all right, I've got more to keep running into. Unless you guys stop me, I'm going to keep them going. We've got some good ones. So I know that between all of us, there's experience with both of these. So I already know my answer, but I'm going to read the question. We're a healthcare architecture firm looking at purchasing a scanner, looking at the Pharaohs and the BLK 360. Can you offer suggestion on which scanner they would be doing as-builts of hospitals, medical offices, including below ceiling and along exterior?
I'll jump in. So the BLK 360 is a phenomenal tool. It is a great tool, but it is not the one-size-fits-all tool that I would argue personally was marketed. It was marketed as. That being said, it has its use cases. We do a ton of healthcare construction. I have a ton of healthcare architecture clients, and so knowing and understanding that market and what understanding what they need and what the end goal is, I think you've got to go with a more traditional terrestrial scanner, whether it's a Pharaoh, whether it's a Leica, whether it's a TopCon. I mean, you pick, but that full tripod-based scanner is really what you're going to want in terms of accuracy, in terms of point density, and kind of getting all that stuff together, especially too if you're using an above ceiling application, right? You're not putting a BLK 360 in the ceiling and getting the data that you need. And so I would definitely recommend, if not a Pharaoh, an RTC 360, a P60, or a TopCon, something like that, for sure.
But not quite the BLK for those types of applications.
No, and it has, if you're doing just below ceiling space planning, right, and you want to document, it's hard to beat the BLK 360 as long as you have the control in place and get the accuracies that you need in order to understand the size of a lab or a clean room or hospital, patient rooms and whatnot. That's a harder tool to keep accurate over longer distances. But it definitely has its use cases.
Yeah, we use the crap out of BLKs, but it's always in small space, right? It's always, on a piece of equipment, maybe it's 2 or 3 rooms, right? But it's not, you're never going to bring it across a corridor in a hallway. If you do that, So I always try to steer away from that question because, everybody has brand preference. So I don't want to impart my brand preference, but there's a lot of research what to do. Price always wins for most companies, though. I will say there's always a price point, and if they're in that price point, there's very few options. So
To plug our prior classes, we had a really good, robust discussion about this in the 101 class. So if you want to go back to the 101 video and kind of, it's probably about 15 minutes of conversation about this topic.
Yeah,
absolutely.
So here's one, and I'll throw from our experience, just because we are doing it quite a bit. Somebody asked, is image texting or texturing from drones on big outdoor spaces for exterior applications? Is that something that we're mixing into this process? So for us, I will say we are, we at least really heavily in our West Coast, we're doing traditional survey work, and we're really finding the use case to combine all of them. We're using our GPS and total station like conventional survey, but then we'll do laser scanning around building facades and complex areas, and then we'll drone for kind of the extended site and roof, and tie all 3 of those together. And again, it's going to come down to, depending on the accuracy you need, depending on the density of data you need, and depending on how you control it. a lot of people are out doing reality capture without survey control, and that gets a lot more difficult if you are looking at combining multiple types of technologies that have different accuracies. If you try to tie a drone and a scanner and things like that inside and outside together without survey, and again, if you don't do it internal, that's fine. You can bring in a third party, but making sure you understand those processes before you mix multiple technologies would be the most important step, I would say.
Surveyors are cheap. I mean, I'm not saying that in a derogatory way. It's a cheap quality process.
Yeah.
What they charge versus the rest of the professionals, side of construction industry, just to get a backbone of quality so you can make sure you have good fit up on whatever the construction you're doing, like it's a couple $1,000s. And I know there's some projects that's obviously going to infringe on the budget. None of these methods are going to work anyways because they're too expensive already. But yeah. I mean, survey control, when you're on a project that's a decent size, $50,000 or more, a couple $1,000s to make sure that you're in the right place is a good back check.
Yeah.
I will always just, and I used to be in the survey, so I have a special place in my heart for those guys and gals, but always need it. Always. Yep. Always.
Yep.
Yeah, I don't think you can combine two different types of, I mean, we talked about multi-tool, projects. I don't think you can really combine those two without survey control. I mean, sometimes we won't even traverse between two floors without survey control. So
I will say for the record though, I do know a lot of cheap surveyors.
There you go.
Right.
Let's see. Don't currently do drone scanning. Is there a drone you recommend to use with our Faro S70 scanner? This class has mostly been about scanning, and you can see how in depth we've gone here. You can get just in depth talking about UAV options, whether you're looking for aerial LiDAR and the benefits of the measuring with laser, if you're looking for photogrammetry,
RTK.
Yeah, I mean, I'll tell you honestly, from our scenario, integrating survey, using it with our Faro scanner, we are running DJI Inspire drones. And again, we see this come down to process and control being just as important or more important than honestly the drone. We've compared our data set of an Inspire, which is a few $1,000 drone, to the data set of a $50,000 photogrammetry drone. If it's controlled properly, we weren't getting much different results. So it really comes down to your control process and your processing and your overlap. But it would depend on your application and your need.
Wind speed, there's so much with drones, right? I mean, it's packaged. I mean, we use a P4 Pro internally. We had an Inspire 2 until it went haywire after an update and went to the side of a building. Nobody was harmed, neither was the building, just the pilot's ego. But
just your pride.
Yeah, it wasn't me, thankfully, because I would have been pretty broken up about it. But right, it's all about, just like these scanners, right? It's all about what you're trying to do. If you're doing facade inspections and you need a smaller package, P4 Pro is great. If you're doing longer range missions, Inspire 2 is a great package as well. So I mean, there's a lot, but Matt said it right. It's most important is control and methods. Less the package, unless you're trying to do, big, huge farm fields and stuff like that. So then you got to really gear up.
Yeah.
It really comes down to the sensor and control in terms of what you can get out. And so the thing with the propellers is less important. But Matt, I'm going to take this as a vote for maybe an STBU class on intro to drones or something. That might be a fun.
Yeah, there is a question already asking about doing another course on using drones. So I mean, again, we've seen tons of questions, tons of people attending these. There's so much interest because people are still getting into this for the first time. Again, we could go in depth on this conversation for every project type, every industry type, because everything is so different. So thanks again for your patience. For those of you whose questions we've not answered, there are a lot of them. Still happy to answer a few more if you guys are hanging out, and we'll still try to do a follow-up on them. But let's see who's next.
I've got one from earlier that I.
Okay, yeah, go ahead.
somebody had asked about hanging, would covering mirrors with a temporary paper masking material help during data collection? This is Tom Murphy. So Tom, yes, there are lots of things you can do. There are people that will mix baby powder with alcohol and spray it on stuff so that you get more reflection on the surface. There are people that will put paper up, but I guarantee you that any one of us and you can clean the data out for the mirror a hell of a lot faster than you can hang paper on the mirror. And so it's just a matter of, the only reason to hang paper on a glass surface is if you want to know where the surface of the glass is. Otherwise, just clean the data because you can do it real fast, comparatively speaking. Real fast.
I think with the Faro training manual, they tell you to put an X across the mirror, if I remember correctly. I think it was Faro. I could be wrong, but they said blue painter's tape across the mirror so you know where it is. And I'm like, yeah, no way.
Yeah.
No.
So there's another question here that kind of goes along that one a little bit. This one's a little more specific. I am using a Leica RTC 360 for my scans and registering in Cyclone, using recap for Q&A, and then point cloud versus design model with Revit models. What's the best way to minimize error while scanning different levels connected through staircases and having lots of reflective surfaces like glass and mirrors? I have 3,000 scans on my project at the moment.
So first, before anybody answers the meat of the question, Kamal, you've got Cyclone and you're using recap for QA QC? Holy crap, buddy. Yeah. Use Cyclone. It's really
use Cyclone. The true slicer, my goodness, that is gold.
Yeah, true slicer. There's so many great QA/QC tools in Cyclone. You've got there's a couple great online classes. Take a look at it. That will save you so much time over doing it.
Absolutely.
And now let's answer the important question.
I guess I can start. I can start with that. 3,000 scans is a lot. I think the biggest project we've ever had was probably like 16 or 1,700 scans, and it was an airport terminal. So I can't imagine. I can't imagine 3,000 scans. But we've talked about it. I think we've already answered the question. Really, it comes down to control. It comes down to hybrid registrations. You know, I think we talked about in the practice run last week. You know, we'll sometimes run. Even if it's a duplication of scans, we'll sometimes run a dedicated control traverse, really tight, targeted control traverse that serves as the spine, it serves as the backbone for the entire project. And then survey control. You know, it's really important that that's getting implemented and that you're bringing in those references. I could never imagine having a project more than 500 scans without making sure we've gone through some kind of survey control process, let alone 3,000. So it's really important to integrate that into your process.
I would say from my perspective, when you get into these large jobs, everything we're talking about amplifies times 1,000. Like you can get by on a small job doing anything you want. You could get by with no control. You can get by without cleaning data. You can get by with reflective surfaces. You can make it work. You can tweak stuff. When you get into massive projects, you can't. You're going to end up with so much built up error, scans that you didn't even notice you had duplicate data of. It really becomes, look, you got to define this workflow and process and follow it to the T through those 3,000 scans. And breaking it up to really treat it like maybe 50 small jobs. You know, if those 3,000 scans are over a really long area, you want to break that up into little phases and treat them as 50 different projects along that length, which means you're going to need survey control within the boundary of those 50 broken up sites. Or if this is a linear 3,000 feet, you're going to need to treat every floor as its individual. And then you have your control process. If it is linear, which I don't know how linear, but you did mention staircases, then what you can do is use your stairs as your base and really bring control in there. Put targets in the stairwell, and do scans just up the stairwells and make that one really tight control loop and do it through multiple staircases if possible. And by putting up the checkerboards, like we've talked about with hybrid registration, if you have checkerboards in the stairwell through the door, then you could cloud to cloud individual floors and tie it down like Sean did, cloud to cloud your floor, and then targeted place it to your control on your stairs. And by doing those mixed processes, you're never going to run into the headache that a lot of people do of thinking you can just cloud to cloud 3,000 scans, which you can't. You cannot just hit process and time together. You'll come back 2 weeks later and it failed, and you really have to break it into smaller chunks.
Well, you can.
Matt,
You
can
can
I
still
just
get
tack
it
on?
light. The software will tell you you can, but and so will the salespeople. No knock on Kelly as a sales guy, because he's the one practical sales type of guy that I met in a software.
There you go.
But yeah, a lot of them unfortunately have. This is sadly, I can tell you dozens of people that I know personally that have encountered the same exact thing. This is not the first RTC or Faro S70,000 plus scan project that said, "What do I do now?"
Yep.
Really, if I want to troubleshoot this quickly for you through here, is take exactly the advice Matt just said. Go back out in your stairwell with targets and hire a surveyor to survey those targets. That's the only thing you can do right now to get good metrics. Otherwise, a lot of time spending trying to do cloud to cloud right now in bundles.
Yeah.
So I'll give you one other thing you can do though, and I don't know if every software can do this. The tools I know to register well with are, Collage, Cyclone, and Recap, right? But in Cyclone, there's some, because you can do a lot of geometry extraction inside of Cyclone. Cyclone has a really cool ability to use extracted geometry as registration objects, and so this is like a lifesaver in Cyclone sometimes. So what you can do is take the intersection of 3 planes, create a vertex, and that becomes a target.
Mm-hmm.
So for things like stairwells where you frequently have intersections of 3 planes, I had a job in Europe where somebody had like a 4-story traverse, like they were on 4 stories of a building, and there were a total of 10 scans in the elevator and stair shaft. That's it. 4 stories, 10 scans. That doesn't work, right?
No, I'm trying to think. Yeah, no.
So literally the way I registered that job, there was, I think, there were probably about 3 square feet of overlapping surfaces between the bottom basement level and the blast scan in the escalator area, right? And literally that was extracting planes on that 3 square feet of overlap, making it a plane and adding that as a registration surface. And then there were columns, the central columns in this building. It was a round building, so there were these 4 huge columns in the middle of the building. Those were extracted on every floor, and those were added as registration objects, and it uses the center line of the column. And so I can't guarantee that it's an accurate registration because that assumes the columns are pretty darn well built.
Mm-hmm.
But it was enough to get the registration done.
Yeah.
Only 3 square feet of overlap. And so like some of these advanced tools, they have really advanced capabilities to go in and create really unique constraints that you can kind of pull a Hail Mary and get stuff to work. And the tools like Recap don't have stuff like that.
All right, we got a question. Oh yeah, go ahead, Sean.
I just wanted to add one last overarching comment to that. Is it personally, and you guys may agree, you may not agree, but I feel like 90 to 95% of registration issues can be fixed with some really good clustering, grouping it down and working at a micro level to macro level is really the way to handle that.
The only time I would say that you can't is linear. For the reasons like I ran into with that project last night. Registered it before I got survey control today, and then checked it against the control. I had little clusters built up, said it was beautiful, it looked good, I sliced it, there's no overlap in lines, but when you get linear, and you go such a long distance, you've got enough accumulated error, you have to have survey if you're linear. I think there's ways to get by with it vertically better than linear.
Yes.
Yeah, absolutely.
I agree.
I know
John Bunn wrote an article on error drift. An excellent article on error drift about 1.5 years ago. So John Bunn used to be at Faro, magnificent for everybody on this still. Read that about linear drift. It's a great article breaking it down.
Yeah.
Mark, do me a favor and send me that link so that we can send it out
We'll
to
include
everybody,
it, yeah.
or post it in the BIM University LinkedIn group. Either way.
Yep. Yeah.
You know, earlier we said planning to fail, failing to plan is planning to fail, and accordingly, what Sean is saying is if you don't cluster, it's going to be a cluster.
Yep. I know we mentioned earlier, sometimes we shy away from sharing, like, okay, what hardware do we suggest? What do we use? What do we prefer? You know, obviously we love ClearEdge. They're a co-sponsor of this, and we love their software. This specifically is about asking about the hardware that we use. You know, I know we've talked about a couple things. We've talked, people asking questions about RTC, about BLK, about Faro scanners, and somebody's asking, you know, hey, it would be nice to hear, even though, you know, sometimes that's an iffy question. What do you use? What do you like? What do you prefer? And I think one of the reasons it'd be nice to answer this is because there's different, you know, there's different answers. Like Mark uses something different. Sean and I think, overlap in some. We rent different scanners at times, and there's different reasons to use them. So I'll answer first and say, you know, I don't love drinking anybody's Kool-Aid, right? I don't use a scanner just because I'm sold on it. You know, somebody sold me really well and I hate the other. We trialed scanners before we bought. We have survey internally, so we QC, we run control. We would know if it was not good for a certain application we were doing. And we also have found over the years that, again, it's really heavily dependent on your control process, your targeting process, knowing how to group things, knowing how to cluster things as to the accuracies you can get. Internally, our main workhorses are Faro scanners. We run the Faro S series 70s and 350s. We have rented and used some Leicas. You know, we don't have any hard feelings against them. When we got Faro, it was a price point. It was good quality. And again, we have used it in every application you can imagine, from interior nuclear to hospital to forensic. We've measured it, we've tested it, we like it. I will say, you know, people will tell you there are hardcore Leica guys, hardcore Faro guys, hardcore Trimble guys that'll like really diss the other. But again, guys, they are all good measurement tools. They are all of those mid and higher end units are acceptable for uses in all of those industries.
Yeah. Hey, why don't just real quick, and then we'll call it a day, and we'll do the follow-up Q&A session offline. But Mark, why don't you tell us what you typically use, and then we'll hop to Sean, and I'll wrap.
Yeah. So, I mean, we're mostly like a shop. Again, it came from survey background and the traversing method on the big projects. Now, there's a couple functional and hardware reasons why we chose to stick with Leica. One, it's just software. We did have Faro equipment. We do have Faro licenses. We still maintain a license for some instances registration-wise, but rarely use these days. But when it comes to the big industrial plants and why we prefer our providers to have it is the dual axis compensation. Like, you get some heavy vibration, some of those catwalks you get up in, and it's not a knock against the Faro instruments. It's just that dual axis compensation they have is not the same level, right? It can take the beatings, and that's why. I mean, our bread and butter is industrial, right? So that's why we just put it and make sure it's a spec that all people do it, as well as they're in the traverse method, because again, sometimes we'll do some scanning in one area, then we got to follow a utility rack, but we don't need scans every 20 feet. You really need one scan maybe every 60, 70 feet or 150 feet. And if you're doing traverse at the same time while you're scanning, it saves a ton of time in the field, tons of time. And has no back office. So it's why we're on the Leica gear. It's not, I mean, we do work with Faro projects. We work with people that use Faro, and it's, I mean, the data's great. The accuracy's there. It's right tool for the right job, right? I mean.
Yep. Yeah, so we're also a Faro shop, and I think what's important, the most important thing to note here, and I think Matt and Mark, you guys have already touched on it, is you've got to pick hardware and software that fits your workflow, not fit your workflow to your hardware and software. And so for us, you know, we have two Faro S350s. We've got an X330, much to the dismay of my Faro account manager. He's trying to get me to upgrade. But you know, for us, we needed lightweight, easy to move, quick in the field. I mean, we're doing 140, 150 scans per crew per day in some cases in some of these hospital things. And so, you know, it came down to cost. I don't think cost was the most important thing. If the Leica solution had been a little lighter, a little more nimble, a little quicker, easier for us to elevate into the ceiling, we would have gone that way. But I think for us, the Pharaoh, you know, the lightweight of that S line, I mean, it weighs next to nothing. And the ability to kind of just fly through, you know, 30, 40,000 square feet a day. It, you know, yes, we have a lot, to counter Mark's point, you know, it's nice to come back from the field and not have a lot of office work, but we're more concerned about getting the footage we need in the day. I'll do the time back in the office. You know, I can't be 3 or 4 days in an occupied hospital wing. I need to get in there, get all our data, and get out.
And that's where
the office time.
And that's where you're best off if you work in a certain industry and certain project type for the majority of your work, then there might be a best unit that would be suggested for you. If you're diverse across, then, you know, they can all get the job done. But it really comes down to, you know, what's a best fit for your majority use case.
Or rent.
Yes, that's what I was going to say.
Or rent.
You know?
Or rent.
I do like that Sean basically said, if you do the crime, you do the time. But yeah, I'm a DAC guy. I hate not having a DAC and a scanner. I don't like scanners without a DAC. It bites you in the butt in so many random positions, and then you have to do so much work in the office to correct for it or deal with it. So I'm like, you know, DAC or bust.
Dual access compensated for those of the uninitiated.
Yes, we actually talked about this in the one class, I think, or maybe it was the 201. Watch them both.
Or both.
But with that, we're going to wrap today. Thank you all. We still have, Jesus, I can't believe we still have 128 people on 36 minutes past. You guys are crazy. We love you. Awesome. Thank you so much. Please, more follow-up questions.
Well,
Matt will do a Q&A session next week. We'll record it and then post it on the LinkedIn group. So check us out there. Yeah, and then we'll get off the air. Matt, any last closing words, and then we'll let Mark and Sean say their byes, and then we'll bail.
Yeah, no, I was just going to say thanks everybody for joining. I mean, obviously with this many people sticking around this long, we know people are enjoying it. They have questions. Our goal is to, you know, we're going to try to keep putting things on like this. You know, not that there's anything settled, but we're thinking of some even virtual conferencey type stuff where there could be more extended ongoing sessions. So connect with all of us individually as well as companies, follow our pages, because if we do more of these, we'll be posting about them. So you'll know first if you're connected with us.
Indeed. Well, thank you, everybody. And yeah, sorry, Sean and Mark, any last parting shots real quick?
Yeah, so I think the most important thing I think that was said today is you know, there's some kind of stigma sometimes in this industry to like reach out and ask and give the tips and tricks secrets. And I really think that all the panelists in all the sessions, including yourself, Kelly and Matt, we're all saying the right thing. I think definitely if there are follow-up questions, reach out to people. I think there's a lot of good people in this industry that are willing to share the tips and tricks of the trade in order to you know, get you to that next level where you're, you know, it's so good for our industry if we're all doing good work.
I will say we only picked guests to bring on this webinar that we like, that know their stuff, that are open to talk with people. Yeah. If you run into a service provider that is not willing to talk with you, I would suggest running the other way because you're going to get a lot further being in a collaborative environment of people who will work together and share knowledge and make sure you get the best product, the best field capture, the best technology, the best deliverables in that collaborative sense. That would be my last parting word. Mr. Mark.
I 100% echo Sean. I mean, as I say in my presentations, always reach out, talk to me. Is there a secret sauce to what we do at SSOE with the scans? Sure, but I can show you something and you're going to use it in a completely different way. And that nothing makes me feel more rewarded is like showing something and then seeing how they blossom and like just absolutely do game-changing stuff with their organization. So I consider a lot what we do, like Sean said, we're all here to help each other, make the industry better. And look forward to collaborating, not with just the gentlemen that are panelists today, but many of you hopefully in the future want to be a panelist and we co-speak at a conference or share a beer together once we're not allowed to do this virtual thing anymore.
There you go.
Or share a beer virtually, and I will make this announcement. I shared it with Matt, but I just decided to do it, so I have a feeling Matt won't complain. We're going to have a Scan to BIM University virtual happy hour.
There you go.
We'll send out details as well for that. But thank you all. Thank you.
That might be okay.
Matt, the best of the best of the best, sir. And with that,
All right, guys. Thank you. We'll see you on LinkedIn.
Cut.
yes.